Welcome to the Demonstrating Implementation Excellence stream of this year's SNOMED CT Expo. My name is Kelly Carew, and I am the Chief Communications Officer at SNOMED International, and I'm very pleased to be introducing our next session today. As a housekeeping note, please remember to use the live Q&A feature in your AirTouch device to submit your questions during the live presentation. All questions will be answered at the conclusion of the session. I'm now very pleased to introduce Erik Sundvall, Information Architect and Researcher from the Karolinska University Hospital, and Daniel Carlson, researcher from the Health Implementation from the National Board of Health and Welfare. Sorry, Daniel. Today's speakers are presenting context-aware interactive use of SNOMED CT and terminology services in openEHR-based electronic health records. Erik, please proceed.
Yes, thanks for reading that long title, so I don't have to. So we can go to the next slide here. And what we're going to look into is pretty old news, actually. The things we've seen very good electronic health record entry screens in the 90s. And now maybe it's an opportunity to redo that work, but with other tools. So let's go to the next slide here. We'll give a brief tour of a tool that was called Clinergy, that was based on pen and pad. There was a lot of work from Manchester University and others. And if we look into that on the next slide, we'll just give you a little, there's a paper about that you can read about in the slides that are available, and there are many papers. And they said, the authors here, John Kirby and Alan Rector, that just having a long list of labels to put on the patient is not as good as having little modular things that you can select to more or less describe things. You can describe a patient with structured entry or in free text. And here they explored how much can you do with structured entry in an efficient way. So let's look at that in practice on the next slide. So they had an old text-based electronic health record system, and from there you could jump into symptoms or diseases and things like this into a graphical user interface. So when you clicked this there, you got into this screen where you first needed to select a body system. So if we look at the next slide, we can see an example of that, what that could look like. So it could be that you take the one with the blood vessels, and then you could go closer into the arm, as you see in the middle picture, and then even closer in and select a specific vein. And when you've selected that, then in the list beside the vein selection in the middle there, with the middle circle, you could only get alternatives that were reasonable for that vein. And when you had selected so far with the graphical user interface, then you clicked the form button at the bottom, and then pops up a form that has entry things that are reasonable for that kind of thing. So that's where you document it in a fast way by just clicking. And this was long before the iPads, etc., were available. So they had thick pen computers, and they could click on these things. It's really amazing stuff when it comes to efficiency, and I haven't seen very much like this in modern electronic health record systems. Let's look at another example here in the next line. So you could select the musculoskeletal part, or the skeletons and joints, I think it was. And here we've clicked on the arm to get closer, and then even closer, and select a specific bone. If they had more time, I think they would have put in a picture of the skeleton instead of reusing a general body picture, but it worked. Anyway, this was used for demo purposes and some research. And there you see also when we selected the radius, I think it's in this case, then you get 3 choices of things that are reasonable to document about this. And then you click the form button, which will take us to the next slide, I believe. And then we've selected fracture for radius. And then we get these different things. And then you see it pops up there, for example, that you can select left or right arm, which would be sensible. And I think we have an example on another slide where we don't need a left and right arm. Where do we have the nose slide? Here, yes. If we select the nose instead, then you don't get the choice between left or right nose, things like that. If you go even further down in detail, you can see that you could select when it comes down to nostrils and things, then it's reasonable to have right and left again. So this laterality choice should also not always be available, but instead they used an ontology underneath as a precursor to SNOMED CT. It's called Galen. And there you could make these intelligent queries to only select sensible things. And we'll try to later show that you can do similar things with the modern tools also. So you don't have to revive this old thing running on Windows XP. Okay, let's go to the next slide. So when they had done this, they had some recommended ingredients how you make such a solution. So Alan Rector and others published a paper where they said that it's good to keep the things apart a little bit here. So you have information models, and you have concept models and inference models. And if you try to make a software like the one you saw in just one big program, coding it in Java or JavaScript or whatever, it will all turn out a mess sooner or later when you want to maintain this. So they recommended split it in these parts. So if we go to the next slide, we can see which parts we are rebuilding this with now. So here we are using SNOMED CT as the ontology instead of Galen that they used. And also the SNOMED CT expression constraint language is used as a glue in between the blue and the orange part there. And that can describe what you want to select from SNOMED CT, but you also need something to call. So we use a HL7 Fire terminology service to send that ECL query. And then for documentation models, we use openEHR, or sometimes pronounced openEHR also, which have information models that are called archetypes that we put these codes inside. And then we've used a system called Better EHR Studio to glue these things together. And the green part we're not showing in this demo today. Let's go into the next one here. So when it comes to the openEHR stuff, you can look this up further in detail later, but we'll need to go on to the demo pretty soon. But the basics are that you have archetypes out on the left here, which are small clinical reusable models that have kind of a maximum data set. So you want to catch everything that could be interesting about the blood pressure, etc. But that's usually too much. You see they're pretty big models. So you go to the next step where you pick several of these archetypes and put them together into something that is called a template. And there you can hide the things that are not useful in this particular use case. So the archetypes are for general use and are maximum data sets. And then when you go to the templates, you put together the archetypes that you want to use and exclude the things that you don't need. And then when you have the template, you can download it from the template tool and upload it to a form building tool that we've done here. And then actually you've got all the descriptions. This could be multilingual also, as you might see there in the template tool. So you get the model in the tree in the form builder there, and you can drag and drop the model onto a canvas where it automatically creates widgets that you can use for data entry. And then you can add logic, etc. And then you can have a form renderer that renders this form in any web application and also makes sure it's validated, etc., and can submit it using standard APIs. So that's the really quick version of the ingredients we are using, and we were inspired by the Cleanergy system. And our little demo is not as fun as Cleanergy, but it can show some principles anyway. So Daniel, your turn.
Okay, so my turn. A quick description of some of the ingredients that we are using that Erik mentioned previously. So we're using the Fire Terminology Service API. So it's a terminology agnostic specification of terminology services. So you could use this API with any terminology, but and it's also not, even though it's called Fire Terminology Services, it could be used outside the Fire framework. So, for example, we're using it here with an openEHR based system, and that works, as we will hopefully see soon, really fine. The File Terminology Service API has specific features for SNOMED, so things like working with hierarchies, ref sets, mappings, and expression constraint language is well supported within the File Terminology Service API. I will just give a crash course into expression constraint language and show some of the things that we're using in the demo later on. So if you want to read more about the expression constraint language, you have the link there. It's an excellent specification. So what the expression constraint language allows you to do is to query for SNOMED concepts, largely at least. So there are various constructs. You could use these less than signs to give all the descendants, that is all concepts which are below a certain concept and in the hierarchy. So for example, if you have less than sign, 2 less than sign fracture of bone, then that's all descendants of the fracture of bone and the concept itself. That is, so this includes this fracture of bone concept. If you use just one less than sign, then it's without the concept itself. There is something called the dot notation, which allows you to take the attribute value. So for example, here we have fracture radius dot finding site. That gives you the value of the finding site for the fracture radius. And in this case, that would be the bone structure of radius. That would be the result. You could limit or constrain the results using the SNOMED attributes. So for example, here we have all the bone structure radius which have laterality, which is a specific side. So it's just one less than side. So it's the direct, so it's the descendants of side, but not itself. So this means left and right, basically. You could do cardinality constraints. That is, you could say that, for example, here that they should be 0 to 0, exactly 0 lateralities that are either left or right. So this would give you all the bone structure radius which have not the laterality specified. And then we also have,
or the nose fracture, like we talked about. The nose should probably return 0 there.
Yeah, that hopefully it should do. Otherwise, you would have to fix that bug. There is a reference set, so we use the caret symbol to denote that we want the members of a certain reference set. And here it's the lateralizable body structure that contains all the body structures which can sensibly have laterality. So this was a very quick introduction into the to the ECL, and now we'll go into the demonstration. Let's see, where is that? There. So this is built using the tool that Erik described previously. It's like a drag and drop tool. We didn't actually provide any coding to be able to build this demo. So I will quickly show how this works, and then we'll talk some more later. So here you see there is a slot called filter, and this is used to filter a query for fractures using the FHIR API and ECL. And you see here we get the result: fracture of nose, open fracture of nasal bone, closed fracture of nose, and so on. So it uses this text filter. Go back to the presentation. This is the file call. This is a bit geeky, but it basically runs this ECL that we see here. Oh, sorry, I should go back. So it gets all the fracture of bone, but it filters with the result that whatever you put in the box in the user interface. So here we entered nose, and then we get a number of options. So we select fracture of nose here. And then this automatically populates the body sites. So these are the finding sites which are specified in the fracture of nose and all the concepts below that. So I will again switch back to the, and hopefully find the right side. This is the fire call. This is the ECL. This is a bit more advanced with taking the SNOMED CT ID of the fracture that we entered in the previous slide. We are finding the finding sites. That is since these are fractured, these are bone structures, and then we're only getting those without laterality, and only those which are structures. We don't want all those entire body structures this time. So we're filtering out the entire body structures.
And the purpose of this is to make the selection list shorter, so you don't get a right and left of everything and all the other things that will be too much to have in a user interface. And then instead we put the left and right in another place that we'll soon see.
Yep. So going back to let's take bone part of nasal septum. That was actually, for those of you who remember, the same information that we entered into Clinergy in the previous slide. So as we can see here, there is no possibility of selecting laterality for this. And if we go to the last of the explanation slides, so here we have again a fire call. Let's see here, there. So what we're doing is we're taking the SNOMED ID of the body structure and we're doing the intersection with the lateralizable body set. And if that is empty, that means that this is not lateralizable, so we don't show the laterality. If it's non-empty, as we will see soon, we will show ability to provide the laterality. Let's try this again. And I will type radius, and hopefully things will happen here. Yeah.
And if you would like to do more like Clinergy, we could have a picture to click on instead of typing things.
No, but we have stuff to get done and 24 hours and so. So let's select distal radius, and there you get the ability, because it's querying SNOMED. Is this a lateralizable body structure? Yes, it is. Let's show the laterality slots. Okay, so that was the demonstration. You see here, if we're using a bone structure radius, because that's lateralizable, this gives a result. But if we take, for example, the nasal septum, or the bony part of nasal septum, that gives nothing as a result. And we're using that to drive this user interface. Some conclusions. So having the right tools for the job, what we were talking about before is that we need a number of components. We need terminologies and information models in order to represent the information about the patient. But we also need the glues in between the terminology and the information model, and that means terminology services, expression constraint languages, and like these no-low code environments that allows us to put this into real systems. And then actually having these tools, which are now becoming available, it's building these context-aware interactive EHR templates with openEHR, SNOMED, and FHIR terminology services becomes a piece of cake. So thank you very much, and hope you have a nice Expo.
Hi, everyone. Thank you so much, Erik and Daniel, for that great presentation. If the audience would like to submit any questions, please go to the live Q&A button at the bottom of your screen and submit those questions now. And I'm sure Erik and Daniel would be very happy to answer them. In the meantime, I'd just like to say I loved the ECL tutorial, Daniel. That was wonderful. It looks like a very nice application you've got there, mixing FHIR, openEHR, and SNOMED together. That's a wonderful use of those three standards. Just one quick question before we go to the live Q&A. Please be submitting your live Q&A while we're talking. Just a question about the order seems a bit different to using a pen and pad. So could you have designed that in a different way?
Yes, we could have. This started out. We were having a education session on openEHR. We were experimenting to see what could have been done, and so this kind of just happened, which led to this presentation. So definitely we could have done, and we probably would have started with you start with the body structure and what you know, rather than going with the finding first. So that could have changed. There is another difference between the pen and pad system and this experiment, and that is that the structure and the information, I would say the information requirements are provided by the template that we use, the openEHR template, and not by the ontology, as in the case of pen and pad. So in pen and pad, the ontology contained was the source of all this knowledge, and the actual interface that we saw in the presentation was built on the fly. So there is a difference here. So the template starts with what's it called, the condition. That is the SNOMED finding. Yeah,
it could be reordered anyway in a user interface, so it would definitely be possible to do it the way pen and pad did also. And then maybe instead of using a lot of pre-coordinated concepts from SNOMED CT, you could instead build an expression and store that, take the parts from the openEHR archetype and put them together to a post-coordinated expression, and that would be probably more logical for the end user. So we'll do experiments with that also. We've made a little pen pad revival website where we'll submit such things, and we've also made an interview with Alan Rector, one of the main researchers behind this, that we've just got up on YouTube yesterday. So we'll share links to that also in the chat here.
Wonderful. Thanks, Erik. So we've got a great stream of questions. The first one was, are you using the lateralizable body structure reference set?
Yes, we do.
Yes, you do.
Of
Wonderful.
course. Yeah.
Wonderful. What's the clinician's point of view on the heavily structured documentation process compared to the more usual free text-based collection of data?
Actually, that would be interesting for you probably to look at the interview with Alan Rector, because this was done with clinicians. So if you've got a clever way of entering things, not as clumsy as our little demo here, but like the pen and pad, then they actually liked it, because sometimes it's even faster to do the clicking than writing things. And you also get questions back from the system. If I say a fracture of radius, and I forgot to say something about if it was left or right, that will kind of pop up in your face, and you can do things in clever ways. And it can also generate text, so that you both store a structured thing that you can use for querying and statistics and whatever, and decision support, and you can generate a text if you do this cleverly.
Very nice.
I also think that there is I don't think it has to be either structure or free text. So you could generate text from structure. You could also at least with the natural language processing get a suggestion for structured data. And also speech recognition, etc. So,
Yes.
so some of the technologies have advanced since the early 90s, so I think there are opportunities that didn't exist back then.
Yeah, definitely. That's probably the way you do. But if you just speak out into the air and you get a free text essay, that might not be as useful as if you speak to a form where there are some free text fields, and the recognition could also see that, okay, now they're saying something that there is a structured field for, so we'll help click things, and then some other things you can tell the computer that now I'm in a free text field and I want to speak freely.
So we all want to avoid the death by 1,000 clicks. That's for sure. But I think not all clicks are equal.
Yeah, and we also want to avoid very long essays that are very different from different doctors and impossible to process afterwards. So getting the good mix, the right balance is the trick. And then you need to do exactly like Alan Rector and the others did, that you do a lot of user-centered design and quick little sprints.
Wonderful. We've got 2 more questions. What's the vision for no-code SNOMED CT processing of the clinical text?
Well, here we actually used the no-code stuff was actually for creating the user interface. So I'm not sure this question matches the things we've presented here.
Maybe the audience can clarify that question, or reach out to you afterwards to get some more information, if that's okay. And one more question. There's a few thank yous from Mikhail and Manisha. The presentation was very insightful. Are these APIs currently integrated into any live application in hospitals? And would you like to share your experience in using openEHR and FHIR hand in hand? So the first, are these APIs currently integrated?
Yes, definitely there are systems using FHIR terminology server APIs, and also openEHR APIs are used every day in real systems. So those are fairly mature. And then, of course, one thing one should think of, maybe you saw there that it was a little bit slow in the interface if we do a live update to a FHIR server for everything, and some things that you select often you could instead cache in the user interface instead. So we make a SNOMED query when we're designing the form for these selections that are always there, and then the complicated things we could send. And now we also sent it to a little demo server far away, so you would probably want to optimize that.
So I think the system that we're using, the openEHR environment that we're using is developed by a vendor, and this is being sold and put in use.
Yes, it's used for 10 million inhabitants in Moscow region, for example, and there are many other big installations.
I think the point of this presentation is not this could be done with other technologies than openEHR and FHIR. It's just happened that these are where we have these tools available at the time, but the principles would be the same with any information standards, terminology APIs. I think you would have difficulties finding something competing with SNOMED, but that's maybe just me.
And me.
Yeah.
And a few of us in the audience. Erik, do you have any final words? We're just about out of time, actually.
I'd like to just share the screen here and tell you where you can find more information and links to the interview with Alan Rector, and we'll also put up more information about our demo so you can run this stuff yourself. So could we share?
Thank you so much for joining us, everyone. We're just finishing the session, so thank you.
Yes, So here, if you go to penpadrevival.github.io, you will find things, and there you can also, we're uploading this interview in 4 parts that I think most or many of you will find very interesting with Alan Rector, where it goes deep down into things.
Wonderful. Thank you, Erik. And thank you so much, Erik and Daniel, for a wonderful session. Really appreciate it. Enjoy the rest of the expo, everyone. Bye.
Bye-bye.